Bet. What is this? 2009, number 3. Okay. So just reading through here. The $120 per meter. And that should make sense because that's like an easy, constant rate, right? If you sell a 2-meter length cable, you're going to make $140. Okay? Super duper. That's all that means. Okay. The cost of producing a portion of the cable varies with the distance, the length of the actual cable. Okay? And they give us that it's 6 root x dollars per meter. Now, that might not make sense, but what I'm hoping you take away from this, if you see 6 root x dollars per meter, you should know that if you integrate 6 root x dollars per meter times dx, what units are we going to be left with? Just dollars. If you integrate dollars per meter, you're left with just with dx, as long as you have the same d with a variable at the end. Okay? So, if the cost for them to make it is 6 root x dollars per meter, right? But that's just to make a certain individual like little slice. Then the integral of that's going to tell us how much it costs to make the whole stupid thing. Okay? And we need to know that because that's what they're going to ask us about here. Okay? So, when they say find the profit, well, all profit is how much money it costs to make, right? Subtracted from how much money it brought in. Well, how much money it brought in is easy. You made a 25-meter cable. So A, how much money are we bringing in? 25 times 120 minus how much did it cost to make this cable? That's just in dollars, so it has to be the integral of that thing, okay? I think a very common mistake, and they might do this, is for kids just to plug 25 into that. If you plug in 25, you're going to get 30, okay? 30 is not the cost to make that cable, okay? It's not the cost to make any real portion of it. It's the cost to make exactly at the 25th meter. Imagine an infinitely thin slice at the 25th meter. That's the cost per meter to make that piece. Which is weird. It's not the cost to make that piece. It's the cost per meter to make that piece. It costs less. You know what? Let's do this. This is not part of the question. Let's say, bam, we have a cable. It looks like this, okay? And this little itty bit right here is right where the 25th meter is. Okay? Exactly the 25th meter. I'm telling you, this right here, now, this we're going to make this semi-easy for us. This is not actually what's happening. We're just going to look. A lot of calculus happens on like infinitely small intervals, okay? We're going to look on a tiny interval, but not an infinitely small interval, okay? So we're saying we make this wire, this length of cable, whatever, in 0.1 meter sections, okay? And each section costs 6 root x dollars per meter. So the 25th, does it make sense that the one before this is the 24.9, yes, meter? So to make the little slice that makes the 25th meter should cost us 6 root 25, right? But that's still dollars per meter. That's still a rate. That would be $30 per meter. Does that make sense? Well, we're not making a whole meter. We're only making 0.1 of a meter. How much is that little slice going to cost us? If it's $30 for a whole meter and we're making 0.1 of a meter, this is not rocket science. I'm not trying to trick you. It's $3. It's $3 to make that little slice. Does that make sense? Okay? Now, that's the basic idea here. That's what that 6 root x means. But the problem is, every single one of these is infinitely small. So we're taking the cost per meter and multiplying it by how thin each slice is, and that's the cost to make each slice. But then we have to add up all the costs, true? And guess what operation adds up everything on infinitely small intervals? The big OS. Yep, the big integral. Okay? We want to add up all 25 meters of them. So it's 0 to 25. That's how much it costs to make it. That adds up infinitely thin layers of this wire, cable, whatever it is. Okay? So that's why over here for A, it's the money we brought in, which is this piece right here, minus the money we got to put out, which is the sum of all these costs of the pieces. Okay? And let's just say we have a calculator for this. I'm not sure if this is a calculator question or not. Go. Am I know what this is? It's 2,500? Good for Mighty Max. $2,500. Easy enough? Okay. So even though, again, I get this question's different than all the ones we've looked at so far. But if you pay attention to the units and you think about what the integral does and what the derivative does, you can kind of reason this together a little bit here. You're also going to notice when they make questions kind of weird, like when they bring in piecewise functions or weird things like that, a lot of times the functions they give you are kind of easy, like 120 per meter is a very easy thing to deal with for us. Okay? All right. A common thing, now this is wrong, a common thing that I'll see kids do, that anybody do this, is they'll put 120 in here, but they'll put an X on there. Okay? That's wrong. Okay? Because the cost was already 120 per meter. If you put an X on it, that means you've integrated it to get 120X. Okay? So that's why I can put it outside, but this right here is the same exact answer as what I just did in A. You can do that right there as well. But don't put an X on the 120. 120 is the rate all by itself. Okay? B says, explain what the integral from 25 to 30. Now, we definitely know that has to do with the cost to make a wire, right? But it's not the cost to make a 30-meter wire. Yeah? 0 to 25 was the cost to make a 25-meter wire, right? 25 to 30 would be the additional charge to turn a 25-meter wire into a 30-meter wire. Does that make sense? It's the difference between making a 30-meter cable and a 25-meter cable. That's what that is. You could also kind of say that it's the cost to make between the 25th and the 30th meter of a cable. Okay? All right, I'm not going to write that all out. You can look it up in the answer key. They explain it pretty much like what I said there, but I'm not going to type that up. Okay? Let's talk about C. C, I think, if you can get A, C is a super easy question. An integral that represents the profit is just 120 times how long that wire was minus the integral from 0 to k of the rate that it costs to make it. Alternatively, you could write this, the integral from 0 to k of 120 minus 6 root x. Okay? And the reason why I throw this question in with all the other ones we've been doing so far is because that is a rate in and a rate out. Rate in is 120. That's the money you're making. Okay? 6 root x is the rate out. So if you integrate their difference, that tells you the total amount of change, which in this case is money we made. Okay? And D says find the maximum profit. Well, you should know that anytime you want to find the maximum of anything, you want to find its derivative. You want to find the zeros or the undefined places for that derivative. And then you want to find the amount at those places. Okay? You also want to check the endpoints if you got them. If you don't have endpoints, then you got to think about the sign of the derivative. Okay? Like you got to check and see if the derivative is going positive, negative, negative, positive. Okay? So D says, I'm going to do it right here, find the maximum profit. Well, here's what I know. Profit is what we just wrote out there, right? 0 to k, 120 minus 6 root x dx. And actually, this is the profit, not on x, on a k length cable. Okay? We want to find the max of that. So you derive it. P prime of k is just 120 minus 6 root k. Okay, that's the fundamental theorem of calculus right there. We talked about that. Is that okay? That's the easy version of it. And we want to know, where's that thing going to be 0? So you say equals 0. And it turns out that means we need root k to be 20, which means k would be 400 meters. That's the only critical point we got. Okay? So realistically, that's going to be the answer, unless we had endpoints to check. But we don't even have any endpoints to check, really. We have 0. But the profit on a 0-meter cable will be 0, so it doesn't make any sense. So this has to be the answer, but we still have to explain why we know it. Okay? So, again, to be redundant, if we have endpoints, you don't need to explain anything about the sign of derivative. You check the values at the endpoints, you check the values of the critical values, the highest one has to be the maximal value. You don't worry about the sign of derivative. If you don't have endpoints to check or anything, and you want to say something's a max, then you have to explain what the derivative is doing, because that tells you where a function is going up and going down. Okay, so we need to see here, and again, this is our derivative right here. Cool. We usually do this in class with a number line, right? Now, your number line is never an answer. Like the graders on the AP test are not going to look at your number line at all. All right, but it'll help us organize this a little bit. If I plug a number in a little bit less than 400, or close to 0, whatever, plug in 1, anything between 0 and 400, what kind of value is P prime going to spit back out? If you plug in 1, or 2, or 10, or 100. Positive, definitely. Which means our profit is increasing until we get to 400. If you plug in anything over 400, it's going to be negative, which means our profit is decreasing after that, which seems weird from a business standpoint. Okay, but that's just the way things are. Okay? So, now we need to write a sentence. What's the question say specifically? The max profit. Oh, we actually have to find the profit at 400. Cool. So we have to find P of 400, which is the integral from 0 to 400 of 120 minus 6 root x dx. Is that okay? I don't know what that is. I think was it 16,000 or something? What is that? Is it 16,000? So you have to find that. It asks you to find that. Okay? And then you write those sentences. I'm going to type it out because my handwriting is abysmal. Okay? And I have a little keyboard here. The maximum profit. I know, right? Thank you, technology. The maximum profit is $16,000. I said 1,600, right? But it's 16,000. Yeah. Did I say? I can't remember. Whatever. It's $16,000 for a 400-meter long cable. Cool. I know this. Oh my. I know this because, and since we defined what P prime was and what P was, we can just use those values. P prime of, this is not where it's supposed to be. This is embarrassing. P prime, P prime, where's prime? Right there. P prime of x is greater than 0 for 0 less than x less than 400. And P prime of x is less than 0 for x greater than 400. So, and you don't need to say this, but I'm just going to sum this up. Profit increases with the length of the cable until what? Until 4, yeah, that's a dumb question. Until 400 meters. And then profit decreases. Okay? So if you were this company, you'd be wanting to sell in 400-meter cables, everybody. Okay. All right.